Thank you so much, sir, for giving me this opportunity. I hope I'm audible with this. Thank you, sir, for giving me this opportunity of representing CPPRI on this dais, I think, today. My presentation will be about addressing safety concerns for producing quality papers, which are meant for packaging of food items. So when we talk about this, it is basically what is this? I think everybody of us is aware that while we are manufacturing paper, we stick to the norms of fulfilling the requirements of optical properties and mechanical properties. But when we talk about food packaging papers, it is also important that the safety concerns are also addressed. So this is one of the basic requirements of producing food packaging papers. So the next of these is, now when you talk about food packaging papers, what are the basic requirements? Basically what? Once it is used as a packaging material, it should not allow the contamination from the exterior to pass into the packaging, inside the package, so that it doesn't spoil the food. And also when it is used as a packaging material, it should not itself be a source of contamination. It should not be something that it itself is toxic and it is in turn leading to the toxicity of the food that has been packaged. So these are the two major aspects which need to be addressed while you're talking about food packaging papers. Now, paper manufacturing, when you talk about producing food packaging papers, it is some of the basic facts of food packaging papers that come to the fore are, first of all, that paper industry uses a lot of raw material, be it the fibrous raw material or it may be a non-fibrous raw material in the form of additives that go into the improving the functionality of the paper. So one aspect is that when you talk about paper, that we have using a diverse, the large amount of what you call additives, and second, that paper industry is water intensive. We know, everybody knows that paper industry is water intensive. Here we talk about reducing the amount of water consumption in the paper industry. So it automatically leads to the recycling and reuse of paper, what you call water in the paper manufacture. So that is another aspect that needs to be looked into. Further, the paper manufacturing in most of the cases in India, I think it is an open process where but the paper making is done in the open. The entire wet web is what you call exposed to the environment, whatever environment is there in the paper mill itself. So that is another aspect we need to take care of. Further, which is followed by one of the basic properties of paper, because we all know it is a very porous kind of has a porous structure. So another problem which comes into force for food packaging paper, that it allows the diffusion of air. It allows the diffusion of air, and it also allows the diffusion of what you call water through the paper. So once this happens, whatever food is there inside the paper, then it will be amenable to being spoiled, because oxidation of the food items would lead to the spoilage. So that these four areas will give you the reasons why you need to look into the safety aspects of paper. Now, so what are the safety concerns of food packaging papers? First is that contamination can arise from either the raw material or any of the additives. Further, the use of contaminated processed water, when you are using high degree of recycle and reuse, you tend to what you call contaminate the processed water. So that's another aspect that needs to be addressed. Finally, followed by microbial contamination from air. We can also have air spores around on the air in the environment, which can again get into the paper and lead to what you call contamination of the paper. Further, once the paper has been produced and once the food has been packaged, again it could possibly lead to the leaching of the chemicals, the additives into the food. So another leaching aspect needs to be again looked into. Now because of these safety, is it working? From there's a pointer to the. So this is what my slide was. So what I was talking was this slide. The meeting the quality standards. This is one of the side what we have a picture is a fungus that we isolated from paper, food packaging paper. The suitability of food packaging paper will depend upon that two aspects, followed by the various basic facts of paper which need to, which provoke our, what do you call, need to ensure safety of the paper. These again, some bacteria and fungal and yeast growth that we got from paper, isolated from paper. The safety concerns. Now, because of all these safety concerns, globally, around the world, all the countries have come out with their own guidelines. So according to the European Union, then we have what you call some what you call migration limits have been set for paper. That's around 60 milligram per kg. And in smaller units, it's around only 10 milligram per, that should be kg, I think. So like similarly in Switzerland, we have the guidelines where recycled fiber cannot be used for paper making. And India, of course, everybody is aware, we have been talking about it, the 2018 notification, which has set some limits on the chemical contaminants. Here we are only talking about the chemical contaminants, not talking about the optical appearance of the papers without specks, without holes or whatever. It's only about the chemical contaminants that I'm going to talk about. Now these are the, the FSSAI norms which are there for various heavy metals. We have only just 1, 2, 3, 4, I think we have just six limits which include the heavy metals, cadmium, chromium, lead, mercury. And please remember this chromium is not normal chromium, it is not the total chromium but chromium 6 in the form of chromium 6, followed by pentachlorophenol and polychlorinated biphenyls. These are the two major organic chlorinated organics which the focus is there. Irrespective of whatever it comes from, I think, from where it comes, you'll have to see where all these contaminants come from. So when you see that paper intended to come in contact with dry food, when you're talking about only the dry food, only PCP and PCB are important. But when it is meant for what you call wet food and for food with fatty surfaces, then all the 6 parameters need to be adopted. You can see this is in milligram per kg of paper. Now lead, now if we have to limit the amount of lead in our paper, then what should we do? We should know the source of lead. Now where does lead come from? It comes from the distribution line, the pumping stations, etc. So what happens is we should look into the water supplies from where we are drawing of processed waters, or also from the colored inks that come, all the white, green, yellow, green colors, they also contain lead, followed. And when you're talking about the ink, the literature shows that the printed papers will have as much as 2 to 10,000 ppm of lead. See the huge amount of lead that goes in with the ink. In any case, this ink comes through the paper, it gets in contact with the food, you tend to contaminate your food. So, but however, in unprinted papers, you can see the amount of lead is only maximum 58 ppm lead was found to be in these papers, unprinted papers. Similarly, this is the various levels of toxicity levels, which can range from anywhere from hypertension. Lead toxicity can lead from anywhere from hypertension to seizures to encephalopathy. So you can see the greater the contamination, the greater the toxicity, and the greater the health hazard for the humans. Now this is cadmium. Now what cadmium normally is used as a brightly colored, this is normally used in the pigments. Now why talking about cadmium, why do we need to look into the limits of cadmium is because the cadmium can bioaccumulate. It can stay in the plants, it can stay in the trees for at least, and with a half-life of 25 to 30 years. If it is to degrade, it will take at least 25 to 30 years to the half of its value. So imagine at least 50 years, 60 years, it is going to still remain in the system. So this is how we need to take care of cadmium. Now cadmium again can cause minor irritation in the stomach, as much as to liver and heart and kidney damage. So see the amount of toxicity it can lead to. So we need to really be careful over the heavy metals. Now again, chromium 6, where does chromium 6 come from? Now chromium 6 can come from either it exists as oxo species such as chromium trioxide or as chromations. So these, it can occur in these forms, and the main source of chromium in paper and paperboard could be chromium trioxide utilized in preservation of wood from the literature that we have found. And exposure to chromium 6 can cause anything from skin irritation to, it can cause genotoxicity, where means even the genes are affected. If the genes are affected, obviously then we can have gene mutation and things like that. So again, very toxic. Mercury comes from the raw material can come from any of the raw material that goes into the paper manufacture. Minute traces of mercury could lead to adverse effects on nervous, cardiovascular, and in higher doses can be fatal to human beings. Can lead to paralysis, insomnia, and emotional instability. So again, we have mercury here. Pentachlorophenols. So now what are these pentachlorophenols? These are organic compounds where the phenol compound will have all the other 6 chlorines, hydrogen substituted by the chlorine atoms. So pentachlorophenols have been used as biocides, It can also be used in wood preservation, but again, they are very toxic. PCPs can lead to neurological impact and also damage of kidney, liver, and everything. So next. This is polychlorinated polychlorinated biphenyls. So you can see the structure of the polychlorinated biphenyls. See, we have two benzene rings with chlorine substitution. Why we call chlorinated is because at least we have 10 spaces where the hydrogen can be got to be substituted by chlorine. So anywhere with the substitution leading from 1 to at least 10 chlorines in the structure will be called as a polychlorinated biphenyl. Again, polychlorinated biphenyls can cause skin problems and also cause liver disruption to functioning of the liver. Now, in view of all these FSSAI norms and the toxicity of all these heavy metals and the organic chlorine compounds, we try to evaluate at CPPRI some of the commercially available. None of these have been directly got from purchased from the mills, but we have got it from the market. Some pizza boxes, cake bases, brown craft also, paper cup, paper bowls, butter paper, everything we have tried. We coded these samples and we tried doing the heavy metal analysis where cadmium was measured, lead was measured, and all these results have been given in milligram per kg. So when you talk about cadmium and lead, you can see that cadmium, most of the results are in BDL. BDL is basically the below detection limit. The below detection limit is of the equipment that has been in use. So when you are using AAS, it will be the detection limit of the AAS, that is atomic absorption. So all these cadmium compounds are found to be below detection limit. Lead, however, was high in some of the cases, but since the amount of lead that is permissible is 3 milligram per kg of paper, so I think none of these were of concern to us. But still, lead is not absent, it is still there. Followed by the total mercury concentration, again BDL levels, none of the samples showed any amount of mercury, and the BDL limit here in terms of, I think, milligram per kg was 0.004 milligrams per kg of paper. And chromium 6 again was BDL below detection limit, so we are very safe till as far as the heavy metals were concerned for all the samples that were analyzed in the lab. Now this is the total organic, this is PCB, that is polychlorinated biphenyls. Now you can see all PCBs, anybody can ask what is 28, 52, 101, 118, these are all different kind of PCBs. All these PCBs means the different amount of substitution of chlorine that goes into the PCB. So that is how these numbers have been given. So all these these are all indicator PCBs, which need to be analyzed to see if it is the PCB is toxic or not toxic. So all the different kind of PCBs were found to be below detection limit of the the equipment. And normally all the PCBs are normally analyzed by the gas chromatography. However, to our shock, because we had been expecting all the results to be all below detection limit, to our shock we found that some of the samples like D and F, which was for kraft paper for us, brown kraft paper, and F was, I think, paper cups, which we got from the market. Probably we got the worst of the paper cup that was available in the market, did show a lot of PCP, pentachlorophenol. Now the limit of PCP is like 2 milligram per kg, but in paper cup we found it to be 8.9. And brown paper, obviously, it was again very high, but since it is brown paper, we thought could probably go into dry food packaging. So these are of concern when we talk about PCPs. Now coming from the results that we analyzed, we try to derive what are the good practices, manufacturing practices which could help us meet all these kind of standards and not be very, what do you call, we have all samples which come below detection limits. So good manufacturing practices then would amount to selection of a proper raw material, monitoring process water or chemicals, monitoring process equipment, proper handling, storage and transport of the product or even the raw material, good housekeeping practices, and even finally which could lead to the conformity to the set norms. If you are able to reach those set norms, I think your paper is safe for food packaging. Now when you talk about proper selection of raw material, what would that mean? When we procure the raw material, it is always procured from reliable sources so that you know what kind of fertilizer or any biocides or anything is going into it. So we know what kind of raw material is going into the irrigation of that raw material. So traceability of the raw material that you are using in your manufacture should be there. Also, before the paper, the raw material is used into the paper making, it is always better to analyze your raw material if any heavy metal contamination is there. Then again, we have the monitoring of the processed water or chemicals. Then again, by processed water, I am telling because even the use of pesticides in India, I think more than 84,000 million tons of pesticide is going into the production of what do you call in agriculture for agriculture purposes. So so much amount of pesticide being used in the country could possibly lead to the contamination of the groundwater from where, or even the soil. The surface water, the groundwater, the soil can all get contaminated even without our knowing. We may be doing our best, but maybe the soil is contaminated or the water is contaminated. So looking at where is the water or raw material contaminated or not. White water when we use in the mills, of course, when you keep recycling, is there any load of bacteria or any kind of microbial contamination in paper? Then we need to look into that. And chemicals also, yes, sir. And we need to look into the chemicals also, what kind of chemicals we are using. Regular monitoring of process equipment, I'm sure you all the mill people are doing this, but we can also do it in terms of when we are talking about any kind of heavy metal contamination. Proper handling, storage and transport of raw material. Basically, you need to hygienically, what you call, handle the raw material, your finished product. They should be stored in conditions where the humidity is controlled so that we don't have any contamination of what you call microbes. And you can see the fungal hypha that we have on the board. These are all been isolated from food packaging papers. So we can always have microbial contamination in papers. And good housekeeping practices, we know that, and conformity to the norms which have been set by FSSAI will go into a good manufacturing practice. And on my conclusion, I would like to say that the heavy metals, the contaminants, any of these chemical contaminants can reach the final product through any of the sources. Commercially available, what you call, food packaging papers have revealed that most of the samples are within the limits of FSSAI contamination, bearing a few, and addressing safety concerns for paper intended for food packaging assumes utmost importance. Putting in place good manufacturing practices can ensure the production of high quality food packaging paper. Thank you so much.